Good evening, my dear Senior 1 student. Our lesson today in geometry is similarity of two triangles. As we talked before, two polygons are similar if their corresponding sides are proportional and their corresponding angles are equal in measure. The similarity of two triangles had three cases. First case, if two angles of one triangle are congruent to their corresponding angles of another triangle, then the two triangles are similar. Which is mean that in front of you two triangles ABC and XYZ, if measure A equal measure X, angle B is congruent to angle Y, so triangle ABC is similar to triangle XYZ. Corollary number 1. If a line is drawn parallel to one side of a triangle and intersected the other two sides or the lines containing them, then the resulting triangle is similar to the original triangle. Which is mean that if you have BC parallel to ED as in front of you, so the triangle ABC similar to triangle ADE. In the first case, you notice that there exist two corresponding angles, two alternating angles, two corresponding angles. Second case, if the side lengths of two triangles are in proportion, then the two triangles are similar. Which is mean that if AB over DE equals BC over EF equal AC over DF, so the triangle ABC similar to triangle DEF. The third case, if an angle of one triangle is congruent to an angle of another triangle, and the lengths of the sides including those angles are in proportion, then the triangles are similar. Which is mean that if measure A equal measure D, AB over DH equals AC over DO, therefore the triangle ABC is similar to triangle DHO. Example number 1. AE and BC are two intersecting chords at D. D belong to line segment BC such that BD equal DC. Prove that the two shaded triangles ADC and BDE are similar. Number 2. BD squared equal AD times DE. First, measure of angle A equals measure of angle B because they are two inscribed angles subtended by the arc CE, and also measure of angle BDE equals measure of angle ADC VOA. So the two triangles are similar, which is mean that triangle ADC is similar to triangle BDE. Since they are similar, so their sides are proportional, which is mean AD over BD equal DC over DE equal AC over BE. Take DC over DE and AD over BD, making crossing multiplication. So BD times DC equal AD times DE. And since BD and DC are equal given, so I replace them and write instead of them BD squared. So BD squared equal AD times DE. Example number 2. In the opposite figure, measure of angle O equals measure of angle DXY. dx 3 cm, dy equal 5, yo equal 3 cm. Find length of XE. Since the two triangles DXY and DOE have a common angle, which is mean angle O, measure of angle DXY equal measure of angle O given. Therefore, the triangle DXY similar to triangle DOE. And we deduce that dx over do equal xy over OE equals dy over DE. Substituting dx and do by their lengths 3 and 8, xy equal 5, so DE equal 5 times 8 over 3, it will be 40 over 3. So xe equal 40 over 3 minus 3 will be 31 over 3 centimeters. Example number 3. In the opposite figure, DE parallel to BC, AD 33 cm, DB 22, DE 2x minus 3, BC 3x plus 1. Prove that triangle ADE similar to triangle ABC and find the value of x. Since DE equal BC as corollary number 1, therefore the triangle ADE similar to the triangle ABC. And we deduce that AD over AB equal DE over BC equal AE over AC. AD equal 33, AB equal 55, DE 2x minus 3, BC 3x plus 1. 33 over 55 after simplifying will be 3 over 5. Then make cross multiplication, so 5 times 2x minus 3 equal 3 times 3x plus 1, which is mean that 10x minus 15 equal 9x plus 3. Moving 9x to the left side and 15 to the right side using the other sign, 10x minus 9x equal 3 plus 15, which is mean that x equal 18. Example number 4. In the opposite figure, triangle ABC is right angle triangle at B, BD perpendicular to AC, BC equal 3x plus 4, BD y minus 3, DA 4.5, DC equal 8. Find xy. Since measure of angle ABC equal 90 and BD perpendicular to AC, so I can use Euclidean theorem, which is mean that BC squared equals CD times CA. 3x plus 4 power 2 equals CD equal 8, CA 12.5. The product give me 100, so 3x plus 4 equal root 100, which is mean 10. So 3x equals 6, which is mean that x equal 2. And since BD power 2 equal DC times DA, 8 times 4.5 equal 36, so y minus 3 power 2 36, so y minus 3 equals 6, which is mean that y equal 9. xy equal 2 times 9, which is mean 18. Exercise 5. Triangle ABC, AB 6 cm, BC 9. Let D be the midpoint of AB. H belong to line segment BC such that BH equal 2 cm. Prove that triangle DBH similar to triangle CBA. Number 2. The figure ADHC is a cyclic quadrilateral. After drawing the figure, I noted that BD over BC equal 3 over 9, which is mean 1 over 3. BH over BA, 2 over 6 will be 1 over 3. So I deduce that DB over CB equal BH over BA equal 1 over 3. And since angle B is a common angle between the two triangles DBH and CBA, so the two triangles DBH and CBA are similar. The second one, cyclic quadrilateral. The cyclic quadrilateral means the quadrilateral whose vertices lie on one circle. Its properties are: each two opposite angles are supplementary, each two angles drawn on the same base and at one side of it are equal in measure, measure of exterior angle equal measure of interior angle at opposite vertex. And we will use this idea here. We noted that from the similarity of the two triangles that angle DHB equal angle CBA. Angle D, again one time, angle DHB equals angle CAB, and they are exterior and opposite interior, which is mean that the figure ADHC is a cyclic quadrilateral. Exercise number 6. Choose the correct answer. The figure in front of you, right angle triangle at B, DE equal 3 and perpendicular to AC. Find length of AE. I can get the length of EC using Pythagoras. Will be root 5 power 2 minus 3 power 2, gonna be 4. And since angle C is common angle between the small triangle EDC and the main triangle ABC, and angle B and angle DEC are right angles, so the two triangles ABC and DEC are similar. Writing the corresponding sides, AB over DE, BC over EC, AC over DC. AB over 3 equal 8 over 4 equal AC over 5. So AC equal 5 times 8 over 4, gonna be 10. So AE equal 10 minus 4 will be 6. In the opposite figure, right angled triangle at A, YDEF is a square, EB equal 8, CF equal 2. Find area of this square. Since measure of angle 1 plus measure of angle B equal 90, angle 1, which is mean that angle BDE, and since measure of angle B plus measure of angle C equal 90, therefore measure of angle 1, which is mean BDE, equals to measure of angle C. And since measure of angle DEB equals YFC equal 90, so the two triangles DEB and CFY are similar, writing the sides which are proportional, D over CF, EB over FY. DE is the side length of the square, we call it X, over CF2 equals 8 over FY side length of the square, we call it X also. Crossing multiplication, so X squared equals 16, which is mean that X equal 4. So the side length of the square is 4. So the area of the square is side power 2, which is mean 16 square units or centimeter 2. And the opposite figure, right angled triangle ACY, angle B90, he said X plus Y equal. We noted that measure of angle ACB plus measure of angle ECD equal 90, angle B plus angle EDC also equal 90. Therefore, measure of angle BAC equals measure of angle ECD, because measure of angle BAC plus measure of angle BCE equal 90. And since angle B and angle T are two right angles, so the two triangles ABC and CDE are similar. Writing the proportional sides, AB over CD, BC over DE, AC over CE. So 3 over 6 equal X over Y, which is mean that 6x equal 3y, so y equal 2x. Applying Pythagoras theorem in the triangle AEC, so x squared plus y squared equals 5 root 5 over 2, which is mean 125. Replacing y and writing instead of it 2x will be 4x squared, so 5x squared equal 125. So x squared 25, which is mean x equal 5. So y equal 2 times 5 will be 10. So x plus y equals 50. Thank you and see you soon.